Once upon a time, physicists were missing something really big, like they didn't even know what they were missing. And their ignorance almost caused an explosion, not like a fun party explosion, more like a World War I kind of explosion. It was the year 1859, and physicists knew something weird was going on with black bodies. A black body is an idealized object that absorbs all electromagnetic radiation that hits it, no matter the frequency or wavelength. It's like a cosmic sponge, but made of metal, like a lump of iron or a bit of charcoal. When heated, these objects would emit light, and physicists had measured the spectrum of that light pretty well. The spectrum is basically a chart that shows how much light of a certain wavelength is emitted. Now, physicists also had a good theory for how this light was emitted. It came from electromagnetic radiation that's emitted from the heated object's surface. Different frequencies of light correspond to different energy levels of that radiation. So to make sense of the blackbody radiation, physicists needed to figure out what frequencies are emitted and at what intensity. They had a decent guess for the formula that fit the data fairly well, except at high frequencies. Physicists predicted that the intensity of the emitted light should increase dramatically infinitely, even while the experimental data showed that it stayed relatively flat. This conundrum became known as the ultraviolet catastrophe, because it predicted that black bodies would emit so much high-energy, short-wavelength ultraviolet light that it would literally burn everything around them. Oops. Physicists were scratching their heads over this problem for years, trying everything they knew to do, and none of it worked. They couldn't even get the basic stuff right. Things like the Stefan-Boltzmann law, which calculates total energy radiated by a black body. They thought they had it figured out, but it turned out they were off by a factor of a quantity raised to the fourth power. This is how physicists spent most of their time back then, making small tweaks to existing theories, not realizing that something completely new was needed. Enter Max Planck, a man whose name would go down in physics history for something he was uneven planning to do. Planck was trying to calculate the molar heat capacity of solids, which is a measure of how much heat is required to raise the temperature of a solid by 1 degree. But to do this, he needed to solve the blackbody radiation problem first. So he sat down with some paper and tried to come up with a better formula for calculating blackbody radiation. He started out by assuming that the energy of the electromagnetic radiation came in infinitely divisible waves. In other words, he was assuming the same thing everyone else was assuming. But then something weird happened. As he worked through the math, he ended up with the wrong answer. The classical result that physicists had been trying to fit data to for decades. But then another thought struck him. What if the energy of the radiation wasn't continuous? What if it was chopped up into pieces like a shattered mirror? He didn't know it at the moment, but that little mental experiment would change the world. Planck had stumbled onto the idea of quantized energy, the revolutionary concept that energy comes in discrete packets, or quanta, not continuous waves. The minimum amount of energy in any system is always a multiple of this constant value. This constant would come to be known as Planck's constant, h. Planck published his results in 1900, and it solved the ultraviolet catastrophe. His formula fit the experimental data perfectly, unlike the classical prediction, which was way off base. But that's not all. Planck's constant paved the way for Einstein's theory of special relativity in the entire field of quantum mechanics. Without it, we wouldn't have lasers, transistors, quantum computers. Modern physics is basically built on this guy's napkin. So why isn't he in the Marvel movies? Planck himself didn't even think his work was that big of a deal. You see, he never actually intended to discover quantum mechanics. He was just trying to figure out how to get the Stefan-Boltzmann constant right. To him, it was just another Monday at the office, which makes this story even more ironic. Planck's constant was supposed to be a constant, a number that never changes. But it turns out that it might not be so constant after all. In 2022, scientists actually proposed that it could vary with time. If true, that means our universe might not be as predictable as we thought. Or maybe it's just another surprise in an already surprising universe. I'm the host of a science channel, and this is our quantum mechanics playlist. Now we've got to go. We're late for a tea party with some rabbits.